So in this lesson, we're going to learn how to solve radical equations. This will be split into two parts. Radical equations means that you're going to have a radical in your equation with a variable underneath. So go ahead and get your heading on your paper. Please pause the video if you need to. We're going to start off with a quick definition of what a radical equation is, and then we'll get into some steps. So can you write radical equation? Radical equation. And that means an equation that contains at least one radical, with a variable term, in the radicand. So just to explain what that means, if we have a radical, and you do not need to put this on here, if you have an expression that has a radical, if you see this right here is your radical sign. This little number right here, this is your root. That's also called your index. Like it could be the square root for a 2. It could be the cubed root. There could be a 3 there. This x, this thing underneath the radical, that's called your radicand. So it is a radical equation if you have a letter underneath your radical sign, if you have an x in your radicand. So here's some examples of radical equations. So I'm just going to write examples. So we've got the square root of x equals 7. There's an example of a radical equation. Another one, the square root of x minus 3 and then equals 5. That's another example. And one more, 2x equals the square root of x plus 6 and then minus 2. These are all radical equations because they all have variables underneath the radical, and we're going to learn how to solve those today. So we've got some steps to solve, and there are 4 of them. So we're going to write steps. And we only need 4 lines, so I'm going to write 4 steps and skip spaces in between each. And we're going to do our first example as we're doing our steps. We're going to have 6 examples for our notes. So I'm going to skip down here, and I'm going to write solve and check your solution. Solve and check your solution. So we're going to start off with the first example that I gave you. So this is going to be example A, and it's going to be radical x equals 7. So here's our steps to solve a radical equation. It's going to be very similar to when we were solving when we had a square. So step 1, can you write isolate the radical? Isolate the radical. What that means is you want to make sure that the radical is the only thing that's on one side. If you look at this first example, there's nothing else next to this radical sign, so we're done with step 1. Step 2, if you think about when we had this equation, if we had x squared equals 7, to get rid of our square, we would do the square root of both sides because the square and the square root cancel out. Same concept. If we have a radical, we're going to square it to get rid of the radical. So step 2 is to square each side. So square each side. And you can't do that until your radical is by itself. So if you look at example A, I'm going to bring this down just so that way you can see what it was originally and what I changed it to. So if you don't mind doing that for your notes. Now what I'm going to do is I'm going to square both sides. So I'm going to put a square on the left and a square on the right. And I like to put my radical in parentheses. The whole reason I did that is because the square and the square root cancel out. So we're only left with what's under the radical. So we just have an x. Then we're going to bring down our equal sign. 7 squared is 49. Now, it looks like we're already solved. We have x all by itself, but if we had more to this, we would do step 3. Can you fill in step 3 for me? Solve the derived, D-E-R-I-V-E-D. Solve the derived. That means new. So can you put new next to that equation? Once you square it, you've now changed the equation. It's called a derived equation. We would solve this. This answer is already done, so it is solved. Step 3 is done. The last thing we want to do is check our answer. So step 4, can you write check all roots? And by that, I mean the solution. So can you put solution in parentheses? So I'm going to just do a quick check in my calculator. When we do the next lesson, we're going to show our check. So I'm going to go to y equals. And I'm going to type in my equation. So for y1, I'm going to put in the left side, so the square root of x. Oops. And for y2, I'm going to put the right side, which is 7. I'm now going to go to my table. I'm going to find this answer and see if I have matching y's. So if I go to my table, I can go all the way down, or I can just go to second in window, because that's my table. And I want my table to start at my answer, 49. I'll go to my table again, and if I go to 49, notice they have matching y's, so I did it correctly. This will work if our answer is an integer. Let's do example B. So we've got 6 total. Can you write the square root of x minus 3, and then next to that equals 5? All right, so step 1, isolate the radical. That means get it alone. It is. It's the only thing on the left. So now I move to step 2. Step 2 is to square each side. So I'm going to put parentheses and square the left, and then square the right. Now I'm going to rewrite my equation. The square and the square root cancel out. I'm left with x minus 3. 5 squared is 25, so now we have equals 25. So that was step 2. Step 3, we're going to solve this equation. To get x alone, you see minus 3. So we're going to add 3 to both sides. 3's cancel. 25 and 3 is 28, so we have x equals 28. Since it's an integer, I can check in my calculator. And again, in our next lesson, we're going to be showing our check. I'm going to go to y equals. I'm going to type in underneath the square root, x minus 3. Go to y2 and type in the right side, which was 5. Hopefully you can see that. My answer was 28, so I'm going to go to my table and find 28. So I can scroll all the way to 28, or I can just go to second window and make my table start at 28. Well, there's 28, and if you notice, they have matching y's, so that means we did it right. 4 more. I'm trying to make sure that we have all the samples that we need. I'm going to switch this. Here's example C. Can you write 3 radical x minus 4 equals 20? We'll put example D over here. All right. First step is to isolate the radical. That means get the radical alone. We've got all this stuff next to this, so we need to move it away. So first we start with this 4 by adding 4 to both sides. We're trying to get this radical alone. 4's cancel out, so I bring down the 3 radical x. 20 plus 4 is 24, so I have my new equation. This radical is not alone. There is a 3 attached to it. So what I'm going to do to get rid of it is to divide both sides by 3. So we have to get rid of whatever's attached to the radical. 3's cancel out. 24 divided by 3 is 8. So I'm going to write radical x equals 8. Since the radical's alone, I go to step 2. That's to square both sides. So I square the left side and I square the right side. The square and the square root cancel out. We're just left with x. 8 squared is 64, so we have x equals 64. I'm going to go ahead and check my answer real quick. I go to y equals. I type in the whole left side. So we have 3 radical x minus 4. On the right side of the equal sign, we have a 20. My answer is 64. So if I go to my table, I'm not even close to 64. So to make it 64, I'm going to hit second window. And I want my table to start at 64. Now I go back to my table and my answer should be right there. Matching y's means I did it correctly. 3 more. Example D. 2 radical x plus 5 and then plus 7 equals 13. Feel free to pause the video and try this on your own and then see if you did it correctly. First thing we need to do is get everything away from the radical. So I'm going to get rid of this 7 by subtracting 7. 7's cancel out. So I bring down the 2. So we have 2 radical x plus 5. 13 minus 7 is 6. I need to get rid of this 2 attached to the radical, so I'm going to divide both sides by 2. 2's cancel out. So I bring down what's left. We have a radical x plus 5. And over on the right, 6 divided by 2 is 3. Since the radical's alone, I'm now going to square it. So I put parentheses on the left side and square it. And since there's only one term, I don't need parentheses over here. The square and the square root cancel out, so we're just left with what's underneath, x plus 5. 3 squared is 9, so we have equals 9. Last step, we have to get the x alone. You see plus 5, so we're going to subtract 5. 5's cancel. 9 minus 5 is 4, so we have x equals 4. I'm going to do a quick check. Grab my calculator. Go to y equals and type in the whole left side. So 2 radical x plus 5 under it. Move it to the right, plus 7. On the right side, we have a 13. Now, my answer was 4. So if I go to my table, I'm not even close to 4. So I'm going to hit second in window, have my table start with 4, and go back to my table, second in graph. If you look, matching answers, so we did it correctly. 2 more. Example E. Erase this up. We have a fraction. On top of the fractions are a radical. We have 2x plus 11 at the top, underneath the radical, and then on the bottom, 4. On the other side, we just have an equals 3. First thing we need to do is get rid of this 4. We see dividing by 4, so a way to cancel it out is to multiply both sides by 4. So I put times 4 over 1 on the left, which means I have to multiply by 4 on the right. So I'm showing you all these different ways to get the radical alone. These 4's cancel out, so we're just left with the radical. So we have radical 2x plus 11 on the left. 3 times 4 is 12 on the right. Since the radical's alone, I go to step 2. I'm going to square both sides. So I square the left, square the right. Square and square root cancel out, so we're just left with 2x plus 11 on the left. 12 squared, that's 144 on the right. Now, step 3, we're going to solve that equation. So we see plus 11, so we're going to subtract 11. 11's cancel. So we get 2x equals 144 divided by 11, that's 133. Last step, to get rid of the 2, we divide both sides by 2. 2's cancel out. 133 divided by 2. That gives me 66.5. So x equals 66.5. I'll do a quick check while you're finishing. I go to y equals. I want this to look like a fraction, so let me move this up a little bit. Hopefully you can see this. So what I want to do to make it look like a fraction is I can hit alpha and y equals. Alpha is my green button, y equals is my gray, and I want number 1 that says n over d. Now I can type in my fraction. So on the top, I do the square root of 2x plus 11. On the bottom, I do a 4. Now, my equation originally was equals 3, so for y2, I'm going to type in 3. If I go to my table, I need 66.5. It starts with 4. So I'm going to go to second in window and type in 66.5. I go back to my table, and I should have matching y's, and I do. One more example, example F. Can you write 3? And then you're going to make a really long radical, because under the radical, we're going to put x over 2. And then next to that, a 15. Looks complicated, but it's not too bad. We need to get the radical alone. Well, we can ignore the inside for a minute. Notice there's a 3 attached to it. So to get rid of the 3, we can divide both sides by 3. 3's cancel out. Now we're just left with the radical. So we have a radical x over 2. 15 divided by 3 is 5. Since the radical's alone, we do the second step. We're going to square both sides. So I'm going to square the left, square the right. Square and square root cancel out, so we're just left with what's underneath. So x over 2 equals 5 squared is 25. To get rid of this 2, we see dividing by 2, we can cross multiply, or we can just multiply both sides by 2. So I'll put times 2 over 1 on the left, times 2 on the right. These 2's cancel. 25 times 2 is 50, so we have x equals 50. I'm going to do a quick check to make sure it's right. So I'm going to go to y equals my, I have a 3, and then I want to have my fraction, or I want to have my radical, so we have the square root. Underneath, we want a fraction, so I can hit either x divided by 2, since it's just single terms, or I can hit alpha y equals, and then make a fraction under the radical. So I have x over 2 inside. I go down to y2, and it was originally 15. Now I go to my table. I have a bunch of decimals from my last example, but our answer is 50, so I can just go to second in window and have my table start at 50. Go back to my table, and notice we have matching answers, so we did it correctly. Please make sure you submit your notes into Canvas to get credit.